We're going to get started again. So, the idea of today and tomorrow is to first of all give you all some experience with design and sort of engineering, design and engineering kind of projects. As part of that, we want to also do, what we're going to do for the rest of the day today is related to design, especially the activities that we're going to be doing in the afternoon after lunch. We have a variety of Connects activities that really are going to focus on simple machines. And so, again, the sort of theme combining the 2 days together, sort of simple machines and then design, engineering design. A lot of engineering, or a lot of design you would do with students that have to do with forces in motion are going to involve simple machines. Almost everything you were doing, most of the projects you all did, or the design projects you just did, involve simple machines, especially the lever is one example. So what we're going to talk about right now for the next however long we'll talk about it, won't be too long before lunch, is the basics of simple machines. This is something that some of you have to actually talk about in class. How many people actually deal with simple machines in the classroom? Okay, so a lot of this will be maybe you, but hopefully maybe I'll bring a little different perspective to this. We'll talk about the basic physics behind simple machines, how to think about them in terms of forces. So what we've done this year, we've talked about forces in motion. We've talked a lot about Newton's laws, what forces are, accelerations, how we relate mass, force, and acceleration. We've talked a lot about forces. We also talked about energy and how to think about energy in different ways, gravitational energy, potential energy, and kinetic energy. Well, simple machines kind of combine both those concepts in a really cool way, and maybe this will help you think about them in a maybe a little bit more systematic and quantitative way than you have before. So what are simple machines? I mean, not necessarily listing them, but what do they do for us? Do they make things easier? I heard the word work. Multiply force. Multiply force. Okay. I think these are all different ways of saying the same thing. What is work? What's that?
When you move an object.
You move an object. Move an object with force. Okay, that combines two of the important things in the concept of work. So work, within the discipline of physics, work has a very specific meaning. It has units of energy. Okay. So work and energy actually have the same units. They're kind of, in some ways, the same thing, but we can talk about them in different contexts. So work, the simplest way of thinking about work is simply force times distance. Okay? Work is simply force times distance. It can be a little bit more complicated. I'll give you a little bit of a sense of how it can be more complicated. Whenever we talk about force times the distance, when we talk about work, so you can apply force, I can apply force to an object without doing work to it, right? I mean, I can go over here and push on this table. Am I doing work to this table?
No.
Okay, why not? Hasn't moved. I'm applying force. I am applying force, but it's not moving. A little bit more, a good example of doing work to an object, or one for you to think about and see if you can explain carefully and properly, is this process. All right? Am I doing work to that object?
Yes.
Okay.
Keep it there, then you're not doing work.
When I keep, that's right. I did work to it. That's right. I'm doing work to it. I did work to it. Okay. Now, now here's another thing for you to think about. How have I changed that object? What have I done to that object?
Restore potential energy resistance.
Okay. I've changed its position, and there's another idea that I heard out there.
You've increased its potential energy.
I put work into this system, and I've increased its potential energy. So I've changed its energy by putting work into it. Okay? So doing work to a system, applying a force through a distance on an object changes its energy. Okay? That can actually be kinetic energy. Okay? When when you, with the catapult or the fulcrum, the lever, you're doing work through some distance, and that changed the kinetic energy of that object, right? Because you launched it. So work is a force times distance. Now this is going to help you understand how simple machines do what they do. What's special about simple machines? This idea of amplifying force, multiplying force. What's that? Fewer moving parts? Is that what
Yeah, few no moving.
Oh, fewer no moving parts. So what are some examples of simple machines?
Screw.
An inclined plane.
Got two of them?
Pulley,
Wheel and axle.
wedge.
Gear.
No, that's not an inclined plane.
Somebody say
Wedge.
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 All right. Here, I've got pictures of them. Okay, so we have, I don't think, so pulley's another one. And this pulley actually, we'll talk about whether it's actually amplifying force in this case. So we got pulley, lever, wheel and axle. I mean, this is one way that the wheel and axle can actually amplify force. Inclined plane, wedge, screw, okay? They all do, in different ways, amplify force, or in this case, a pulley. We'll talk about pulleys in particular. We actually have several activities. You have a specific activity that we have assigned to you to do today. I've also set up, Alice and I have set up a kind of a exploratory station over here for you to mess around with pulleys and think about how they work. So how does this work? How does a simple machine amplify force? How does it? So let's talk about work. So one of the things that you have to recognize when you talk about simple machines and you talk to your students about it is you're not getting something for nothing. Okay, you can't get around the laws of physics. You're not getting something for nothing. It is making something easier for you, but you're not. You're actually paying for it in another way. Okay? And it turns out the way that we experience the world is in terms of forces, really. Energy is kind of more of an abstract concept. What we actually experience is force. When we pick up something heavy, what we're experiencing is force, right? And what we want to do is lower the force rather than worrying about thinking about energy. What am I trying to say here? So forces and energy. So this is one way of thinking about it. So let's talk about this process, because this actually may be kind of confusing. Because what I just said is that if you do work to an object, it changes its energy, right? So one thing that your students would immediately say to you to try to trip you up is, what about this process? I applied a force to this book across the table. How has its energy changed? Where did the energy go when I pushed it? I'm putting work into that book sliding across the surface. Where did the energy go? Is it changing its potential energy? Is it changing its kinetic energy at the end of the day? Is it changing its kinetic energy? So where did that work go? Yeah. So the work you do goes into heat. Okay. So you're applying this force. You're doing work, and that work actually, in this case, is actually getting converted into kinetic energy. Some of it's going into kinetic energy. You're moving the object, but the object stops and converts all of this kinetic energy into heat. Okay? So the simple way of talking about this is when you do work to a system, it changes its state, its energy state. Okay? But that doesn't mean that energy can't leak away somewhere else, and that's what's happening here. The energy's leaking away to friction. Okay? All right, so let's talk about this simple machine, a pulley, okay? Within the language of simple machines, it's good to think about, and we actually started talking about this. I think you all have some of this language, and I may be using slightly different terminology, and I'm happy to use different terms here, but I'm going to talk about the effort. There's the effort side, and there's the load side, right? The effort side is where you're doing the operator is pulling on this, or you have something pulling, and you have a load that you're trying to move. Okay, so this is the load force or the load load, which is applying a load force, and this is where effort's applied, and this is an effort force. So what's important here, when we think about these two, this is where it's important. It's important to compare those two. That's where we're going to determine something that's called, what's the word we use, the amplification of force. There's a particular word we use. It's mechanical advantage. Okay, so there's actually a number we can come up with for the mechanical advantage of a particular machine. This machine I've just shown you here, do you think there's any mechanical advantage? Are we getting mechanical advantage of more than one here? No. This pulley's not really amplifying force. It is doing something interesting though. It is a machine that's doing something helpful. It's redirecting force. It's allowing us to go.
But also it seems like too, you could, if like instead of just pulling on it, if I sat on the string, then gravity is helping, like my weight is, so it seems like.
Oh, right. It helps you.
Something like that, you know.
Well, exactly. Well, I think you're pointing something that's really important out, and that is this pulley allows us, the pulley and the string allow us to apply forces in completely different directions to pull this mass upward. We're actually applying a force downward and pulling a mass upward. We could be pulling that force. We could be applying that force in any direction actually if we use pulleys in the right way. So that's one thing pulleys do. It's not amplifying force though. Okay. So how do we amplify force with it? Well, so let's also, before I get to that, let's think about why let's look at this process. So there is a ability to change the direction of the application of force. That's great. But one of the things that I want you to pay attention to here, and I think you all, it's pretty obvious, if I want to move this thing up 1 foot, how far do I have to pull on this side? Okay, this is crucial. This is what will help you understand how simple machines work. Okay, to get any kind of force amplification, that equality between the movement of the load and the movement of the effort is no longer going to be the case. All right. In this case, we have a one-to-one movement of effort and load, and that actually turns out to mean that we have a one-to-one correspondence to the force on the effort side and the load side. Everybody with me? Okay, this is one way to talk about mechanical advantage. Mechanical advantage is simply this force over this force, right? So if you have, if I just lift an object, if I just lift this water off the ground, the load force and my effort force are the same, so that's mechanical advantage of 1. There's not really any mechanical advantage. But if we put simple machines together in the right way, we can lift a heavy load with a very small force, and then we're going to be getting a mechanical advantage that's much more than 1. All right?